Here are the minimum requirements to use Ethernet IP with the Productivity Series CPUs. For the Productivity CPU to communicate to the Nitra valve, these are the communication parameters that we will need for this setup. So the input data is what we're reading from the valve, and the output data is what we're writing to. The input, as we see here, consists of 5 bytes. The output word consists of 2 bytes, or 16 bits, 1 bit for each possible solenoid on the valve. To set up the CMV valve for Ethernet communication, you will need to obtain the Ethernet IP configuration tool from our website. So navigate to our site and under Download, select Software. Find the Ethernet IP software, download, and install it into your PC. Once installed, open up the Ethernet IP configuration tool and then select Scan for Devices. Once you see your OEM device, select and put in the IP address you need for your system. I'm going to use the following IP address for this example. So open up the productivity project you will be using. Double-click on the hardware configuration and then select the Ethernet IP tab from the top. Now drag the generic client into the gray area. You can place an individual tag for all these elements, or you could check the box Use Structure. This will create a structure of tags that can be used for this device, making it a lot easier on the programmer to create, use, and find the correct tags. I'm going to select the Use Structure and give it the following name. Now give your client a device name. Type in the IP address that we configured into the CMV valve. Now the TCP port of the CMV valve will always be 44818. Click on the green cross, select Add I/O Messaging. These tags will also be part of the original structure created above. This tag will become important later. When it is enabled, it will start the reads and writes to the data block at the RPI that we select for each data block. Here you can see that there are 3 tabs. Let's start with the input data block. From this information, we can see that the assembly instance should be 101. Now this data array portion is the part that catches some. The data array data type that we use here must match the data size of the input data blocks. So we can see that the size of the input data block is in bytes, and there are 5 of them total. So we need to create a data array of an 8-bit type which matches the bytes and has at least 5 columns. So type in the name of the data block you want to create. And when you select the number of elements, you will then be asked to create this array. Select the data type as 8-bit unsigned and increase the number of columns to 5. Select OK, and then increase the number of elements to 5. Now select the Output tab. The assembly instance here is 100. I'm going to name my output data array as the following, and when I select the number of elements, I'll be asked to create the array. Change the data type to 8-bit unsigned and the column size to 2. Click OK. Now change the number of elements to 2. Now to set up the configuration word. Enter the assembly instance of 3. I'm going to enter the following data array, and when I click on the number of elements, this dialog will show up. Change the data type to 8-bit unsigned, and the columns can remain as 1. Select OK, and then the number of elements can remain as 0. That completes the client setup to the valve. When we select OK here, we will be completing the creation of the structure for this device. Next, we need to address the solenoid outputs in the output data block. From this table, we can see how the 2 bytes address each of the solenoids that are possible to the valve. So if we take the 2-column data array that we created, this would be how the outputs are distributed inside that array. So I'm going to place a normally open contact with this Boolean to trigger the bit of word that would address the first solenoid. Now, if you remember from the configuration, we had an enable bit. When this bit is enabled, the auto polling of the input and output blocks will begin at the RPI rate that we selected in the configuration. So I'm going to make a normally open contact with this Boolean to trigger the enable member of the device structure. That completes the ladder code. Now transfer that to your CPU. With the project transferred and the PLC in run, let's open up the data view to quickly test our code. Enter the tags to enable the comms and control the first solenoid. Send the edit to first enable the communication. Now send the edit to turn on the solenoid. You should immediately see the valve turn on. We can also view the status of the read by entering in the input block data array. This table defines what the status word indicates on the valve. If you need any help with using an Automation Direct device, please contact Automation Direct's free, award-winning technical support team during regular business hours. They will be happy to help. And don't forget the forums. There's lots of folks there that love to share their years of experience. Just don't post questions directed at Automation Direct's technical support staff there. They do not monitor the forums on a regular basis.